Hey everybody, my name's Jason Eaton. I'm a Chief UAV Pilot and Operations Manager for a company called Airborne Inspections. We're here today, we're going to talk to you a little bit about doing aerial structural and thermal analysis using drones. So, without further ado, let's bring on the drones. A lot of buzz about drones in the last couple of years. And as you can see in the photo, there's all kinds of them out there. When we first started out, there were very few, and we had to actually build our own. But then came on the boom. And with that, a lot of manufacturers wanted to jump onto the bandwagon. What happened was a lot of people decided that, hey, we're going to buy one and fly it anywhere. And it kind of made things a lot more dangerous for people like us that are trying to operate commercially within the rules, and just for the general public. Anyway, there's a lot of different types of drones, as you can tell, a lot of different configurations. These are all basically your prosumer kind of units. And you buy the drone you need for the specific condition or purpose that you have in mind. The difference between prosumer drones and professional drones is, well, we'll actually get to that a little bit later, but you think about the flight controller in general and what the drone has to deal with. When it's in the air, it's taking commands from you as a person, as the controller. It's also dealing with wind and what you're telling it to do and pointing a camera. And so the brain and the drone's actually having to do a lot of different things. The difference between prosumer and professional is usually a professional drone will have maybe 2 or 3 brains instead of just one. And it makes it just a lot safer to operate. We're going to talk a little bit about legal versus illegal operators. This has been a big issue for us in industry. It's really hard to go out and quote on a job when you've got somebody that goes to Best Buy and picks up one of these little white ones, say, and comes in behind you and actually says, oh, well, I'll do it for $50 or $100. The thing with that is, and what clients, I'll say, don't understand, is if they get caught actually flying illegally, commercially, they're looking at a $5,000 fine, or up to $25,000 fine, and up to a year in jail. They want to take the risk, fine, but the odds are they don't have the skill, they don't have the experience, and they just don't know how to operate professionally. On the other hand, we're really relatively safe when it comes to these things. We do have some new regulations coming out this year, which are very exciting. It's really going to make our jobs as commercial operators a lot easier, and it's going to really kind of thin the herd for the people that try to be professional but just quite aren't. So we're really excited for these new rules to come out. Anyway, let's get into what we're here to talk about a little bit. We do building envelope inspections. We do rooftop inspections. We do all kinds of inspections, but currently we do a lot of residential and commercial, apartment, condo complexes, things like that. And traditionally, people use swing stages. And I love this picture. It's just kind of, I find it kind of comical. It isn't, it's very dangerous. And that's part of the thing about swing stages. It's very dangerous. It's very expensive. It's very time consuming. You think an average job with a swing stage will probably take you anywhere from a week to 3, and maybe another week or 2 to get your report out. And last I heard, I believe they run at about $1,500 to $2,000 per drop. So every time they have to move the swing stage and drop it over, that's another $1,500 to $2,000. And it gets up to about $20,000, $30,000 range depending on the size of your building. So what we decided to do is we decided to fly it. We decided to fly it with a drone for a lot of different reasons. The quality of data that we can provide you is second to none, basically, to what you'd actually get from a swing stage. You've actually got a permanent visual record of what's happening on your building. Our time to delivery, you can give us a call this week, and we can be probably on site early next week and have your report done within 3 to 4 days. So suddenly your time to delivery went from 4 to 6 weeks to 5 to 10 days, and that's a lot quicker. We can provide accurate measurements of that, and talk about safety for a second. The FAA down in the United States, the governing body for airspace down in the United States, have just released a test that they did. People think drones are scary and they're going to hurt you if they fall down and all these things. Well, A, we pay a lot of money, so our drone doesn't fall down. But B, what they found was they took a 5-pound rock, a 5-pound block of wood, and a 5-pound drone and dropped it on a crash test dummy, each of them. And believe it or not, the drone is the one that actually did the least amount of damage. And of course, the blades, well, they spin fast and they'll cut your skin a little bit, but nothing compared to a block of wood, say, falling from the top of a building, dunnage, or if a brick kind of fell off. So they're actually quite safe. And so far as cost goes, we're generally around 1/3 of what it would cost you to actually hire a swing stage and go and do a traditional inspection that way. So say if your swing stage is going to cost you about $30,000, we'll probably get in there anywhere from the $7,000 to $10,000 range and have your data to you so much faster. I'm going to talk a little bit about a drone. This is my favorite part because I love the drone. It's just a lot of fun. We use this particular model. It's called the Aztec or Ascending Technologies Falcon 8 for a variety of different reasons. It's an expensive machine, but we pay for peace of mind. The first thing about it is this Aztec Trinity flight controller. What we really like about that is, just like manned aircraft, the Aztec Trinity has 3 sensors of everything. So, and you think of all the sensors on a flight controller, you've got a barometer, you've got accelerometers, just like on your cell phone, moves, and they're all very sensitive components. Now, on a prosumer drone, if one of those components fails, it's going to fall out of the sky. On ours, if one of those components fails, we have 2 others on board, so it's just going to pick up where it left off and carry on. The shape of it's very interesting too. If you'll notice, it's what they call a V-form octocopter. It's got 8 propellers on it, as opposed to 4. And it's built that way for 2 reasons. One, it's really stable in high winds, and it's just really stable in general compared to a lot of the other machines. And 2, because there's 8 propellers, if 1, 2, or even 3 of the propellers fail, I can still carry out the operation. I can still finish the mission. Whereas if it's a traditional quadcopter, if 1 propeller fails, it's going to fall out of the sky. So we really like that. It's German engineered, so quality control is second to none. It's been proven 6 years in industry, this particular machine, and it's one of the very few in the world that's actually allowed to fly on offshore oil rigs. If you know any of the regulations that are involved in that, it's a very, very pretty heavy deal. Intel just acquired Aztec as of last year, and they've got a new model coming out this summer that we're really looking forward to. And the new model, Intel has developed what they call real sense. So we can actually, the drone can actually see something 30 feet away and not fly into it. And we find that very exciting, especially when you're flying up the side of a building 30 feet away from it. You really don't want to get any closer. Well, real sense will actually help us stop and doing that and be safer. This is what it looks like in action. I just love this thing. It's an amazing, amazing machine. So I just want to take a minute and explain a little bit about what we use to actually fly. This is the controller that I actually fly with. Pretty big unit, but basically the 2 sticks in the middle, I've got throttle on one side and yaw, so it'll actually spin the craft this way. On the other side, I've got pitch and roll. Up here is the ground station, so I can actually perform automatic functions on the machine through the ground station and control camera. I can do calibration, just get right into the system settings while it's in the air. That's really important. This side over here is what they call a diversity receiver. So what happens is the machine itself sends a video signal back down. This picks it up and sends it into the monitor. Oftentimes when I'm flying, I don't actually look at the machine itself. I'm looking at what I'm seeing on the camera on the machine. That's why I have a visual observer beside me. But I find it a lot easier to fly from the actual bird's eye view, the perspective of the drone itself, just to maintain, what do you call that, a perfect focal length when I'm taking photos. And I've actually got my photo trigger right on the stick here, which is really handy. It's not a function that I've had on any other controller. These just basically tell me what function I'm in, so either in GPS mode or what they call height mode. I flip this one up, I'm in full manual mode. This is like my key, my turn key, so when I want to start the machine, I push this one up. And this one lets me control some functions on the camera, like the shutter, record video. That's pretty much the ground station. I can also plug this into a computer so that I can use the actual manual ground station. And it's a great piece of technology. I'm going to grab the drone. The battery goes in the back, slides right in. It's a relatively simple machine. One of the things I like about it that no other machine really has is actually an on-off switch. Very, very handy. Nonetheless, one of the reasons we really like it, if you look at the size of the motors, they're really, really small. While it's running, I can actually stick my hand in here and grab one of these motors and it'll stop. I don't have to worry about it really cutting me. It could if I don't grab it right, but at the same time, it's built so that it will stop on impact. This down here, this little black piece, that's the antenna for my video transmitter. So what's happening here is it's actually taking the data from the camera, sending it into the brain, and then from the brain back out into the transmitter that's therefore sending it down into my ground station, so as that both myself or the engineer or my photographer can actually take pictures. It's a very unique build, but there's good reason for it because it's been proven in industry for 6 years, and they really haven't changed it at all compared to a lot of the other companies in the prosumer market that keep coming out with something new every 3 months. So it's really well trusted, especially across the UK. It's about to hit the North American market very, very soon. So a drone's only as good as the sensors that it actually carries. Yes, of course, the flight characteristics are very important, but without sensors on it, what are you doing with a drone? You're flying it around for fun. And although it's a really incredible platform, I'm going to talk a little bit about the two primary sensors that we use on this particular machine and why we use them. The first one is the Sony A7R. It's a 35 millimeter sensor. So it's a full frame censored camera at 36 megapixels. The images that you can get from it, as you can see, you can actually, from that far away, pull in and see the degradation that's on the side of the building, or the roof in this particular case. And in this photo, again, you can see how far away I am, but you can also see the cracks and the swallowing that are happening right at the top, where you wouldn't be able to see that otherwise. Let's see. This is part of what you get when we stitch together, say, about 15 images for a roof. So from this high resolution image, you can still zoom in to about 3 or 4 grains of sand and get a really, really good quality data for what you're really looking for. So like I said, it's 36 megapixels. The cycle time is about 0.8 seconds per full resolution photo that I can take, which means I can fly really fast and take a lot of photos. I don't have to stay in the air for half an hour or 45 minutes. I can actually capture the data in 5 to 10 minutes and take 200 or 300 photos. It's just amazing overall. It's great technology. The FLIR Tau 2 is industry standard in thermal inspection. And this really excites us because it really gives us the advantage to get a perspective that you can't get from thermographers on the ground. And if you'll look at this camera, you'll notice there's actually 2 cameras on board. The one to the left is the actual thermal camera, and the one to the right is a 12 megapixel full color camera. The reason we really like that is because simultaneously we can actually shoot thermal and RGB and give you both side comparison in your end product. And it's just an amazing idea. On your right, sorry, You can see that the top couple floors on this have been covered with EIFS or EIFS. And this building was done about 15 years ago. And you can see where the seams are actually seeping and leaking. Now, if you look at the image on the left, you can't tell that with the naked eye. In this case, they're doing a retrofit on the building this spring, so they called us in to see what kind of condition it was in and whether or not they had to actually replace all the IFS. And at the end of it, I'm pretty sure they decided to replace the IFS. As you can see, there's quite a bit of degradation. This is I actually stitched this image together myself. It's not the greatest by any means, but this is about 6 floors of the top of this building. And that's part of the quality that you're going to get if you get us out there to actually run inspections on your buildings. We don't only do high rises, we can do stacked towns, we can inspect generally anything. And as you can see here, actually the image on the left, there's 2 roofs there in stacked towns, and you can obviously tell there's an issue there. And these ones are new, so we can come in and inspect new development and make sure that the contractors are doing their jobs properly, or we can come in 5 years down the line and just check out the lifespan of the products that you're using and making sure that they keep up. So the Tau 2, I'll just give you a couple of quick specs about it. It's a 640 by 512 pixel resolution. It's pretty much, it's not as high as you can get, but it's as high as you can get on a drone. We'll give it that way. The 30 hertz part might be a little confusing to you, but in general, people that fly these thermal cameras on drones get 7.5 hertz. The biggest difference is, with ours, we can shoot at 30 frames a second. So you're getting clean video, clean thermal video out of it. Whereas with the 7.5, you're getting 7 frames a second. So it's kind of like a security camera where you get chunk, chunk, chunk. We really like it for that. It does have a zoom. We've got multiple color palettes, as you can see. And depending on who your thermographer is, we actually have 2 level 1s and a level 2 thermographer on board, as well as a PENG to help you out on that side. Anyway, and I'm going to talk about radiometrics in a bit once we move on. I want to talk to you a little bit about analytics. And now, okay, we've talked about how to capture the data. What do we do with the data? What's up with that? Well, we can do radiometric analytics, which means we can do spot temperatures on even inches away from each other. Say you've got a 30-degree spot here and a 7-degree spot there, but your engineer needs to know that temperature variance. We can give you that. We can do volumetrics. As the image down below here, that's an open pit mine. We can fly over that mine and actually measure how much dirt has been removed from the earth in that spot, or actually measure how much dirt is in a pile of earth that you've just moved, which is kind of cool. We can do a 3D point cloud, or a 3D rendering of your entire building, which gives you a high resolution 3D model of your building for your engineers to inspect later on, and as, again, for record, and also provide you with an orthomosaic, which in English is, imagine 300 pictures all glued together like a puzzle and coming out with one really high resolution image, and that's what an orthomosaic is. We can get very, very accurate. We get down to about 2 centimeters per pixel. And a pixel is really, really, really small. So when you think about ground level, 2 centimeters kind of speaks for itself. And we can also do area measurements, volume measurements, and right down to square footage if there's, say, a panel that needs to be replaced and you want to know how much that is. This is what we use as a ground station. So if we're flying a roof, say, it's an automatic pattern. It takes its pictures automatically. It actually records the GPS locations to each photo automatically. And it flies it rather quick. I've flown a lot of different machines, and this one just goes really, really fast. This next image is the software that we use to render. And what's happening here, all these blue little squares that you're seeing on the screen, those are the actual photos. And what the software is doing is actually generating a mesh, a 3D mesh from that photography. And down below here, you can see that it can actually draw cars. It can draw whatever it sees in 3D real time. So when you're moving into a 3D render, that's basically what you're going to get. And this particular software is from FLIR, and it's made specifically for analyzing high quality thermal data. So no matter what you need, I'm pretty sure we can get it. We'll talk about reporting for a sec. And I think this is probably one of the most important parts of this whole aspect is what do you get at the end of the day? We've spent a lot of time and trouble trying to find the right type of system to provide a deliverable for you. And we think we've actually really nailed it. The software that we use is called Expanse, and it's made by a company called Sky Futures out of Austria, I believe. And what it does, what it is, it's an enterprise cloud platform that's built specifically for industrial inspectors and drones. These guys have been flying drones for probably 7 or 8 years doing inspections. They had to find a way to actually communicate the data. They wrote the software, and we're using it. It lets us upload and edit videos, record inspection observations, organize reports for multiple assets, tag your observations on 3D models, share analysis with multiple stakeholders, so we can send you a link. You can therefore send your link over to different engineers. They can pull it up on their desktop, their tablet, their phone, what have you. It's very, very interesting. And we can create even just a single repository of all your buildings together just to compound the value. Not to mention we can come back every couple of years and do it over and over. If there is a 3D rendering or we generate a 3D rendering for you, this is kind of what you're going to see when you log in. Obviously the spot in the middle is the building itself. On the left are all the different reports that we've created. On the right, I've actually selected one of the red spots. Red, orange, and yellow is by degree of severity of what needs to be done or what damage there is to the building. And on that right pane, you can see that little image there. Down the right pane, basically it tells you exactly where we took the image, what time we took the image, the description of what we're seeing, of the report, and our recommendations as to what we think you should do with it. Once you click on that image, it'll actually blow up into a full screen thing. If you don't have a 3D model of your building, this is generally what you're going to see. And so we do up an executive summary, the scope of the work that we've done, what we think should be done to the building, like our closeout, and what we think you should do. Now, if you click on the View button, just on the right there, on any one of those reports, it's going to come up something like this. And you see on the building, there's a little black circle with a 1 and a 2 there. And over into the right pane, there's also a couple of links. So what happens if you click on that 1 or that 2, then it'll bring you right into that particular anomaly. So you can actually, instead of looking through all the pictures and trying to find it, just click on the spot that we've already found for you. Down on the bottom here, there's the picture of the building. There's the actual thermal and RGB photo that we did. And in this particular one, I threw in that full face in thermal as well. So you click on it, and it brings you in, and you can see how we can highlight different spots on the image to show you anomalies. In this particular case, there's a coating degradation happening. You don't really need thermal to tell you there's a coating degradation there. But in this image, once you bring it up full screen, this is a different image again, but you can see where the thermal comes in, and there is no coating degradation here, but there's definitely some water seepage happening in the seams. Up in the top right corner of this window, there's a button that says Observation, and what that'll do is that actually pulls up a little box window that just basically gives you the observation for that particular spot on the building. And yeah, you can print it too. I know everybody likes to print reports, and they're really, really handy, especially to hand off to contractors when you obviously need them to go and do some work on the building. Not only do you have a printed, documented, permanent record, but when it comes time to say, contractor, I need you to go to XYZ on this building and fix this. Here's the picture. Here's exactly what's going on. Write your notes in. Thank you, sir. Go to work. And that's pretty much. It's an all-around really great reporting system, specifically for drone operations, or any operation for that matter. I'll talk to you a little bit about how we do what we do and what it takes to do what we do. I'm going to be really quick on this. But we operate safely, and that's our main concern. Generally, our crew consists of an operations manager. They're the ones, or myself in this case, that actually organizes the entire operation. There's a pilot in command, the guy that actually flies this thing, which is, again, myself as well. Sensor operator, he's the guy that controls the camera. So if you're an engineer, if I'm piloting and I've got an engineer with me, I'd much rather have a camera operator beside me and have the engineer speaking to the camera operator as opposed to speaking to me directly, because I'm too busy actually flying the machine. We got visual observers, and their jobs are to keep your eyes on the sky, make sure there aren't any conflict with other aircraft, and ground supervisors, just to keep pedestrians and vehicular traffic at bay. We have to keep 100 feet from, well, we have to keep everybody 100 feet from the drone, basically, so far as Transport Canada is concerned, in Ontario. And that's why we have ground supervisors. We usually tape off our area quite well and make sure that there's just no foot traffic in and out. The operations manager, and this is where it gets kind of tricky, is we are licensed by Transport Canada. We do have the ability to basically fly anywhere in Ontario. The license is called a Special Flight Operations Certificate. We've got what you'd call a restricted complex with night ability, so we can actually fly at night as well. We have to coordinate with Transport Safety Board in case we have an incident. They're who we report to. They're kind of like our insurance company. And they're not there to slap us on the wrist if anything goes wrong. They just want to collect the information and find out what we're going to do to mitigate in the event something went wrong. Thank God we've been incident-free. We also have to coordinate with NAV Canada, so I have to literally submit a flight plan, just like manned aircraft, for every operation that I do. It's a very quick process, but nonetheless, it just informs all the other pilots around, same with the NOTAM, as a notice to all airmen, that we're in the air at said location, at said time, flying at said altitude, and please don't fly across our path. We also carry a radio with us, so that if we need to contact an airplane, we're licensed to actually speak to air traffic, which is good. Certain cases here, we're in a pretty heavy control zone, so I have to actually call up Flight Control Center or nearest ATC half hour before and after our operation, just to let them know I'm starting and I'm done. And in certain cases, we have to coordinate with municipality if I've got to fly off public property, anything like that. We're insured up to $10 million for liability, so we pretty much got you covered that way. And what we do in general, because we've got this 100-foot rule, is if we're flying within 100 feet of anybody else's property or anybody else's building, we go out anywhere from 24 to 48 hours ahead of time and post notices on all the doors with our phone number and an explanation of the operation, and just saying, hey, there's going to be a drone flying in your backyard. Don't be alarmed. If you got any questions, give us a call. It's okay. It's all legal and safe. And we're concerned about people's privacy as well, especially when we're flying high-rise buildings. I've got stories. I've got stories. But basically what we'll do is we'll actually post notices in the building as well, probably 3 days in advance, so as that if you've got an issue with privacy, don't be walking around at 6 o'clock in the morning with your curtains wide open, making coffee. If maybe you want to clean up your patio, what have you, because we are taking a lot of pictures. But we want to make sure that the public is also comfortable with what we're doing while we're doing it. Why do we have to do all that? Well, airspace is kind of like the 401, and it gets pretty tied up. That's pretty much why we go through all the steps to be as safe and mitigate as much risk as possible. Run through really quick how it works. It's really simple, actually. Contact us. We encourage your engineers to come and talk to us if you've got a specific problem area on your building. Otherwise, you want the entire building done, just let us know. We start with a civic address, and from there, we'll go in and operations will take over. We'll go out, we'll actually capture the data, do what we need to do that way. Once it's captured, obviously we analyze it, and then we report on it. It's that simple. It's 4 steps. It's not as hard as people think. Here's some of the technology partners that we work with. So I like that slide because it's just a lot of big names. It's a lot of fun. That's it. So if you have any questions, I'd be happy to answer them.